Greetings, everyone. Learning is a hobby here. I decided that I am going to be posting my lecture note, sorry, not lecture notes, my chapter summaries and exercise sets for my supplementary resources for Logic to my supplementary resources to Peter Smith's course on an introduction to formal logic. So in this video, I'm going to go over chapter one of the resources, which is this book here. This is Introduction to Logic by Irving Copi, Carl Cohen, and Victor Reutich. I have the 15th edition, but there's later editions, newer editions if you're looking to pick yourself up a copy. But I would suggest because new copies are so expensive. I think an earlier edition is more than fine. Um, I wanted to go through this one because Irving Copi apparently was a student of Bertrand Russell's, so I was interested in reading his logic, introductory logic book. So that's what I'm going to do in this video. I'm going to go through my summary for chapter one. I did the exercises already for chapter one, but I'm going to skip over them in this video because I just want to do the summary, and I'll make another separate video on the exercises. So let me just bring up the notes. Chapter one here is a little bit longer and it goes over quite a bit more than chapter one in Smith's book, but Smith does cover the same material, just he does it breaks it down in a different way, as well as the other resources that I'm going to show you in videos that I'll make later on. Okay, but let's look at Copi's book right now. So here's my summary. Okay, we start just like Smith does with what is logic, and this is Copi's definition. I don't know if it's Copy or copy. I'll probably end up saying both as the video goes along, so just bear with me. If you could correct me down in the comments, that'd be great, so I know actually how to say it. But anyway, logic is the study of the methods and principles used to distinguish correct from incorrect reasoning. Very similar to Smith's definition, unsurprisingly. All right. Next, we're going to look at propositions and arguments. The nice thing about Copi's book is he does have definitions explained in the chapter itself, but on the side in the margin, he has actual, written down like um, definitions from my mind is going blank here from a not encyclopedia from a sort of like a dictionary definition. Sorry about that. Maybe I need a cup of coffee or something. But anyway, here's the definition of proposition: a statement, what is typically asserted using a declarative sentence, and hence always either true or false, although its truth or falsity may be unknown. And this is a pretty standard definition for what we mean by a proposition. Sometimes books will call it a statement, but I think he does mention this here in the chapter. So let's continue. Here's a note. When we assert some proposition, we do so using a sentence in some language. However, the proposition we assert is not identical to that sentence. So again, this is sort of one way that logicians think about propositions. Uh, in one of the other resources that I have, they talk about this sort of technicality as well. But anyway, um, let's go through this. Two sentences may be different but have the same meaning. Also, the same proposition may be asserted using sentences written in different languages, for example. So, Leslie won the election and the election was won by Leslie have the same meaning, right? They assert the same proposition. And these four sentences here, each written in different languages, also have the meaning and the same meaning as the English sentence, it is raining. Right? The very same sentence can be used to make very different statements, to assert very different propositions, depending on the context in which it is expressed. So, for example, the largest state in the United States was once an independent republic. This was once a true statement about Texas. However, stated today, it's a false statement about Alaska. Propositions may be simple or compound. For example, the Amazon basin produces roughly 20% of the world's oxygen, creates much of its own rainfall, and harbors many unknown species. So the above example constitutes what we would call a conjunctive proposition. A conjunctive proposition is equivalent to asserting each of its component propositions separately. We also have disjunctive propositions and hypothetical propositions. In disjunctive or alternative propositions, no one of the components is asserted. In other words, a disjunctive proposition may be true, but any one of the components may be false. This is sort of the sense where we connect things together with the word or, right? That's what we mean. The inclusive or, anyway, not the exclusive or. That's what we mean by disjunctive propositions. And a hypothetical or conditional proposition asserts an if-then statement, which may be true even if both components are false. Right? In logic, the internal structure of propositions is important. Right? Next, we get to arguments. Right? Let's define inference, a conclusion, and the premises from which it is inferred, or in other words, an argument. Drawing an inference, inferring a conclusion from premises is a process by which one proposition is arrived at and affirmed on the basis of some other proposition or propositions. So this is what we mean by an inference. So we infer a conclusion from on the basis of some propositions. All right, an argument is any group of propositions of which one, the conclusion is claimed to be supported by the others, which are called the premises. The conclusion of an argument is inferred from the premises of the argument. Right, the conclusion, these are all definitions here. In any argument, the proposition to which the other propositions in the argument are claimed to give support or for which they are given as reasons. The conclusion is the proposition inferred from one or more other propositions. And the premises in an argument, the propositions upon which the inference is based, the propositions that are claimed to provide grounds or reasons for the inferred conclusion. Some inferences or arguments are warranted, which meaning correct. Others are not. Arguments are the chief concern of logic. Smith also told us this in his chapter 1, as logicians were concerned with the form of an argument, not with its content. Again, also Smith mentioned this in his chapter 1. The simplest kind of argument is one that consists of one premise and one conclusion. These may be stated in two separate sentences or in one single sentence. The order in which premises and conclusions occur in an argument may also vary. However, no single proposition can be an argument because an argument consists of at least one premise and one conclusion. All right, here's an example. Part A, if a state aims to be a society composed of equals, then a state that is based on the middle class is bound to be the best constituted. This is one proposition in which neither component is being asserted as true. It's a hypothetical or conditional proposition, right? Therefore, it is not an argument, right? However, we can restate it as we do in Part B. A state aims at being a society composed of equals, and therefore a state that is based on the middle class is bound to be the best constituted. This one is an argument. There's a premise and a conclusion whose truth is inferred from it. Right? Although every argument is a structured cluster of propositions, not every structured cluster of propositions is an argument. All right, so that's section 1.1.2. As I said at the beginning, I've actually already done the exercises for chapter 1, but I'm going to skip them here because I want to do them in a separate video. And Copi's book is one of those types of books where actually the chapter is broken up into some explanations, and then you have like an exercise set, and the chapter continues and so on. So I'm going to actually skip over the exercises here and then just continue with the rest of my summary for the chapter, and I'll do the exercises in a different video. So just bear with me. Okay, recognizing arguments. So conclusion indicators and premise indicators. All right, we'll start with a conclusion indicator, a definition of that. A word or phrase such as therefore or thus appearing in an argument and usually indicating that what follows it is the conclusion of that argument. All right, and here's a partial list of conclusion indicators. Therefore, hence, so, accordingly, in consequence, consequently, proves that, et cetera, et cetera, et cetera. I'll let you pause the screen if you want to see them all. I won't read them all out. Right. And then we also have premise indicators. In an argument, a word or phrase like because or since that normally signals that what follows it are statements serving as premises. We also have a partial list of those over here. And again, I won't go through all of them, but you can pause your screen and read them all if you want to. So for example, since, because, for, as, follows from, et cetera, et cetera. Okay, arguments in context. The above indicators may help indicate the presence of an argument or identify it at its premises or conclusion, but such indicators do not necessarily appear. The full force of an argument or counter-argument can be grasped in most circumstances only with an understanding of the context in which those arguments are presented. In real life, context is critical. Right, premises or conclusions that are not in declarative form. We have, for example, rhetorical questions, a sentence or utterance used to make a statement, but which, because it is because it is in interrogative form and is therefore neither true nor false, does not literally assert anything. Using questions to express a premise is sometimes counterproductive because it may invite answers that threaten the conclusion at which the argument aims. Questions can serve most effectively as premises when the answers assumed really do seem to be clear and inescapable, leading a listener to provide the apparently evident answers for themselves. Leading a listener to provide the apparently evident answers for themselves uh, I couldn't even read my own writing there, augments the persuasiveness of the argument. And arguments that depend on rhetorical questions are always suspect because the question is neither true nor false. It may be serving as a device to suggest the truth of some proposition while avoiding responsibility for asserting it. That proposition is likely to be dubious and it may in fact be false. So it's wise policy to refrain from arguing with questions. In some arguments, the conclusion appears in the form of an imperative. A command, like a question, is neither true nor false and cannot express a proposition. Assertions of a command can be reformulated into a statement that something should be done. The differences between these, if there is one, will not be explained here, says the author. A proposition that functions as a premise may take the form of a phrase rather than a declarative sentence. Right, then we get to unstated propositions. Arguments are sometimes obscure because one or more of their constituent propositions is not stated but is assumed to be understood. And then we have the definition of an enthymeme here, an argument that is stated incompletely, the unstated part of it being taken for granted. All right, that's what we mean by an enthymeme. A premise may be left unstated because the arguer supposes that it is unquestioned common knowledge, or an arguer may deliberately refrain from formulating a critical premise, believing that by allowing it to remain tacit, the premise is shielded from attack. The effectiveness of an enthymeme may depend on the hearer's knowledge that some proposition is false. To emphasize the falsity of some proposition P, a speaker may construct an argument of the form, if P then Q, where everyone knows Q is false, not Q, which is the unstated premise, not P is the conclusion. Right? Arguments and explanations. Passages that appear to be arguments are sometimes not arguments, but explanations. And this is where things can kind of get a little bit vague. The common indicator words cannot settle the matter because these are used in both arguments and explanations. If an author writes Q because P, how can we tell whether he intends to explain or to persuade? Well, one way is we can ask, what is the status of Q in this context? Is Q a proposition whose truth needs to be established or confirmed? If yes, then because P is probably offering a premise in its support. In other words, we have an argument. Is Q a proposition whose truth is known, or at least not in doubt in that context? So here, context is very important. If yes, then because P is probably offering some account of why Q has come to be true. In other words, the author is probably offering an explanation. In an explanation, one must distinguish between what is being explained from what the explanation is. If we are sensitive to the context, we'll usually be able to distinguish an explanation from an argument. All right. There will always be some passages whose purpose is uncertain. These passages may deserve to be given equally plausible readings. Interpreted one way, they may, you might consider them to be an argument. Interpreted as another way might be interpreted as an explanation. I'm going to skip this exercise set 2 because for the same reasons I skipped the other one. So I'm just going to skip these and finish up the chapter here. Deductive and inductive arguments. There are two very different ways in which a conclusion may be supported by its premises. Thus, there are two classes of arguments, deductive and inductive. We talked about this in chapter 1 of Smith as well. Understanding the difference is essential to the study of logic. All right. Case 1, a deductive argument makes the claim that its conclusion is supported by its premises conclusively. If its premises are all true, that means its conclusion must be true. Right? Whereas in case 2, an inductive argument does not make such a claim, but that its conclusion follows with some probability from its premises. Every argument is either deductive or inductive. Right? This brings up the concept of validity, a characteristic of any deductive argument that cannot have all true premises and a false conclusion. Such an argument is said to be valid. Validity is a formal characteristic. It applies only to arguments as distinguished from truth, which applies to propositions. Right? Just a note here, deductive arguments that fail to be valid, meaning premises don't guarantee the truth of their conclusion, are said to be invalid. And every deductive argument is valid or invalid. The central task of deductive logic is to discriminate valid arguments from invalid ones. Right? There are traditional methods, which are called Aristotelian syllogistic logic, and this is rooted in the analytic works of Aristotle, which are explored in chapter 5, 6, and 7 of Copi's book. We will be studying Aristotle's work in general as part of my study of the early philosophers as well, if you're following along with that series on my channel. Right now, we just started Plato, though. Right, modern symbolic logic is explored in chapter 8, 9, and 10. The central task of inductive arguments is to ascertain the facts by which conduct may be guided directly or on which other arguments may be built. Empirical investigations are undertaken, leading to factual conclusions when inductive techniques are applied appropriately, most often concerning cause and effect relationships of some importance, scientific arguments, for example. Inductive arguments make weaker claims than those made by deductive arguments because their conclusions are never certain. The terms validity, and invalidity do not apply to inductive arguments. The higher level of probability conferred on the conclusion by the premises of an inductive argument, the greater is the merit of that argument. We can say that inductive arguments are quote unquote better or quote unquote worse or weaker or stronger. We explore inductive arguments in depth in chapter 11, 12, 13, and 14. And actually, I have an entire book that's solely devoted to inductive arguments that I'll introduce later on. Not in this video, obviously, but later on the channel. Because an inductive argument can yield no more than some degree of probability for its conclusion, it is always possible that additional information will strengthen or weaken it. In contrast, the conclusion that follows with necessity from the premises of a valid deductive argument follows from an enlarged set of premises with the same necessity, regardless of the nature of the premises added. Right. So in other words, a deductively valid argument is always deductively valid no matter how many premises you add to it. All right, validity and truth. A deductive argument's validity resides in the inference relation between the set of propositions that serve as the premises and the one proposition that serves as the conclusion of that argument. A deductive argument is called valid if and only if it cannot have all true premises and a false conclusion. Therefore, validity can never apply to any single proposition by itself. Truth and falsehood are attributes of individual propositions, whereas validity and invalidity are concepts of deductive that can be applied to deductive arguments only. Right? Truth is the attribute of those propositions that assert what really is the case. Truth and falsity are the arbiter of individual propositions. I'm sorry, is the attribute. Truth and falsity. Again, I'm sorry, I'm having trouble reading my own writing here. It's kind of it's dark outside now, so my eyesight is worse at night. But anyway, truth and falsity are attributes, sorry, of individual propositions or statements. Validity and invalidity are attributes of deductive arguments. We've already said this a few times already. You're going to see in the references, the other supplementary references, there's going to be overlap between them, obviously. But I'm using different books here because they give different viewpoints, slightly different viewpoints on things. So just as the concept of validity cannot apply to single propositions, the concept of truth cannot apply to arguments. So deductive arguments are either valid or invalid, whereas propositions are true or false. The relation between true or false propositions and valid or invalid arguments are critical and complicated. These relations lie at the heart of deductive logic, so we're going to explore that. An argument may be valid even when its conclusion and one or more of its premises are false. A deductively valid argument cannot have all true premises and a false conclusion. I don't know why I wrote that again, but it's important to keep in mind. Consider the following arguments. Okay, and we have a few examples here. All mammals have lungs. All whales are mammals. Therefore, all whales have lungs. Right, and all of these are numbered for a reason you'll see in a second. Argument number 2: all four-legged creatures have wings. All spiders have exactly 4 legs. Therefore, all spiders have wings. Argument 3: if I owned all the gold in Fort Knox, then I would be wealthy. I do not own all the gold in Fort Knox, therefore I am not wealthy. Argument 4: if Bill Gates owned all the gold in Fort Knox, then Bill Gates would be wealthy. However, Bill Gates does not own all the gold in Fort Knox, therefore Bill Gates is not wealthy. Argument 5: all fishes are mammals, all whales are fishes, therefore all whales are mammals. Argument 6, there's a reason why he's going through this. Just bear with me. All mammals have wings. All whales have wings. Therefore, all whales are mammals. And finally, argument 7, all mammals have wings. All whales have wings. Therefore, all mammals are whales. All right. The truth or falsity of an argument's conclusions does not by itself determine the validity or invalidity of that argument. Moreover, the fact that an argument is valid does not guarantee the truth of its conclusion. So from the examples that we have above, notice that some of them have true premises, some of them have false premises, some of them have true conclusions or false conclusions, some of them are invalid, some of them are valid. So the invalid arguments here are 3, 6, 4, and 7, right? Arguments 3 and 4 have true premises. 3 has a true conclusion. 4 has a false conclusion. Argument 6 and argument 7 have false premises, whereas argument 6 has a true conclusion and argument 7 has a false conclusion. And arguments 1, 5, and 2 are valid arguments. Argument 1 has true premises and a true conclusion. Notice that there are no valid arguments that have true premises and a false conclusion because that can't happen for a valid argument. And then argument 5 and 2 have false premises. Argument 5 is a valid argument, whereas argument 2 has a false conclusion. It has a true argument 5 has a true conclusion, whereas argument 2 has a false conclusion. All right. Sound arguments is defined next. An argument is sound if and only if A, it's valid, and B, it has all true premises. Given A and B, a sound argument must have a true conclusion. So only a sound argument with contingent conclusion can establish the truth of its conclusion. To learn about reality and especially about causal regularities, scientists deductively infer the logical and empirical consequences of a scientific theory or hypothesis without knowing whether the theory or hypothesis is true. They compare the deduced consequences of a theory or hypothesis with observations and, where possible, the observational results of experiments. If the deduced predictions agree with observations, then the theory or hypothesis is confirmed or corroborated. And if the deduced predictions disagree with observations, the theory or hypothesis is disconfirmed or refuted. Another word for that is falsified. In everyday life, we must often choose between alternative courses of action. To avoid deceiving ourselves, we must reason correctly about the consequences of the alternatives. Taking each alternative as a premise, we infer the consequences of each action or premise, seeking to determine the course of action with the most desirable consequences. So if we just confined ourselves to arguments with premises known to be true, would therefore be self-defeating. Prudent conduct is based on prudent decision-making, which is based on good reasoning. All right, and that's chapter 1 of Copi's book. So let me stop the screen share here. All right, I have a couple other, like as I said, resources on deductive logic, or introductory logic. So I'll be posting those as I go along as well. Um, so you'll see all of them, I guess. I will talk about them also in my March vlog. But anyway, I'll leave you guys here for now. The exercise set will be in a separate video. So I'll see you in the next one. Let me know what you guys think down below, and I'll see you in the next video.